Hello guys, welcome to recitation number 6. So it says all questions on the quiz are about the problem shown here. A bullet of mass 15 grams is fired from a gun into a 3 kilogram block of wood. After the collision, the block and bullet, so the bullet sticks in the block, so it's a perfectly inelastic collision. When they stick together and then it moves up to a height, swings up to a point 10 centimeters above the starting point. So that's the diagram we have there. And let's find a way to solve this problem. Where's my marker? Okay, let me make sure you guys can see. And we are all good. Okay. All right. So we have a couple of questions before we solve this problem. Let's start with the first question here. So the first question says, what are the objects that need to be included in the system so that you can solve for the velocity of the bullet? So all we need to solve the velocity, since we're already given the height, we have nothing to do with the rope. We just need the block and the bullet. They're not asking us for a recoil velocity of the gun, so we don't have anything to do with the gun. So just the bullet and the block will solve this problem. So the only thing you need is the bullet and the block, so that's B and C only. Okay? And that's question 1. Question 2 says, considering the collision of the bullet with the block, what kind of collision is this? I've said that already. That's a totally inelastic collision. You know, not every collision that bounces back is an elastic collision. Sometimes you have some, they don't stick together, but it is still inelastic. So the way you treat collisions basically is to calculate the total kinetic energy before collision, total kinetic energy after collision. Are they the same? Is total kinetic energy conserved? Total before equals total after? Then it is an elastic collision. But if the total before is more than after, some is lost to heat, then it's an inelastic collision. But when they stick together, you know it's inelastic already. But when they don't stick together and you are not sure, calculate the total kinetic energies before after. But now they stick together, so it's a totally inelastic collision for that. Okay, next. So it says, considering the problem from the time just before the collision of the bullet with the block until the block reaches its maximum swing height, which of the following are conserved? Total energy, always conserved. Total linear momentum, always conserved. Kinetic energy, For an inelastic collision, kinetic energy is not conserved. Gravitational potential energy is not conserved. Is that okay for this? So kinetic energy here has half mv squared when the bullet strikes the block, but here the velocity is 0. Potential energy here is 0, potential energy here is maximum. But total energy is conserved. Total mechanical energy, if you like, is conserved for the system. So only A and B is correct here. Total energy and total linear momentum. The rest are not conserved. Okay? Now let's go to the main problem and solve the problem. So let's do the calculation. So I have total momentum before collision. Total momentum before collision. So before collision, all I have is the bullet. Mass of bullet, initial velocity of bullet. Plus mass of block, initial velocity of block. But initial velocity of block is 0 because the block was at rest before the bullet came. So let's look at total momentum after. Total momentum after collision. So mass of bullet, final velocity of bullet, plus mass of block, final velocity of block. But they stick together. So final velocity of bullet equals final velocity of block. I call it just V, capital V. So total momentum after collision becomes mass of bullet plus mass of block. They have the same velocity V. So from law of conservation of linear momentum, these two should be the same. These two should be equal. Okay. I don't know if you guys can see this part. Let me take it backwards a little bit so you guys can see. Okay. Yes, so now I think you guys can see everything, right? Perfect. Yes. So I call this velocity V. So these two are supposed to be equal. Total momentum before mass of bullet, initial velocity of bullet, equals total momentum after mass of bullet plus mass of block. times v. So this is one equation. But I'm being asked to find the initial velocity of bullet, but I don't even know the final velocity with which the bullet and the block swing together after collision. So I'll have to find this first because I can get this from conservation of energy. So when the bullets strike the block, the kinetic energy they have here, the total mechanical energy is zero, potential only kinetic, half mv squared, is converted to potential energy at the top here when the final velocity is zero. So half mv squared here equals mgh here. Okay? So half mv squared at collision, half mv squared, the capital V they both have, equals mgh at that height. And this m right here is going to cancel, is the block and the bullet together, but it's going to cancel on both sides, so it doesn't matter. So half mv squared at collision of the bullet with the block equals mgh when they reach at the top there. So here I have half v squared equals 2gh. So v is 2gh square root. That becomes 2 times 9.8 times 0.1, which is 10 centimeters. You convert to meters, 0.1. So when you do that, 2 times 9.8 times 0.1, and you take a square root, let's see what we get. Two times 9.8 times 0.1. 1.96. Let's take the square root of 1.96. 1.4. So the final velocity v with which the bullets move together to cause that height. So from the height, you can tell the kinetic energy that produces the height. That's what we are doing right now. So the height is 10 centimeters, 0.1. We are finding the velocity that can, the kinetic energy velocity that can give that height, that gravitational potential energy. And it's giving us to be, the answer to be 1.4 meters per second. So this is the final velocity v with which the block and the bullet swing. So I put that in here. I can find the velocity of the bullet. Okay. So solving this, mass of the bullet is given to be 15 grams, 0.015 times initial velocity of bullet equals mass of bullet plus mass of block, 0.015 plus 3 times, we just got v to be 1.4. So if you solve for velocity of bullet, 3.015 times 1.4 divided by 0.015, that gives you the velocity of bullet. So initial velocity of bullet is 3.015 times 1.4 divided by 0.015, and that just gives us the answer we have there, 281.4 meters per second. That's the initial velocity of the bullet. So we walk backwards to get that, to solve that problem. Thank you guys. I'll see you guys next recitation. Have a good one.